For our next topic on fluid statics, we're going to talk about gauge pressure versus total pressure. That's often a subject that's poorly understood and easily confused. What is that? What do we mean with gauge pressure and what do we mean by total pressure? All right, let's say again, like in the previous example, we're trying to find the pressure at the bottom of a pool. Let's say the pool is 4 meters deep, it's filled with water. We want to know the pressure at the bottom. And so, first of all, what do we really mean by what's the pressure at the bottom? Well, we'll get into that in just a moment. We saw that the equation is that the pressure is equal to rho g y, rho being the density of the liquid, g acceleration due to gravity, and y is the depth of the pool. So y is the depth of the pool, and again, negative direction means a positive value for y. Plug it in the values, we get the density to be 1,000 kilograms per cubic meter. G is 9.8 meters per second squared, and y then would be 4 meters. And let's see here, that would then be equal to 39,200 newtons per square meter, or pascals, as we like to call them. All right, that's units for pressure. But what did we find? Did we find gauge pressure? Did we find total pressure? What is it? Well, we only accounted for the pressure caused by the weight of the water. We did not account for the additional pressure caused by the atmosphere pushing down on the water. So in essence, what we found here was we found the gauge pressure. And so if we want to find the total pressure, right here, here's the relationship between gauge pressure and total pressure. Gauge pressure is the total pressure minus the atmospheric pressure, so we're only finding the pressure caused by the water. So if we want to find total pressure, P total, that is equal to the sum of the gauge pressure plus the atmospheric pressure. So if we're going to find the total pressure here, we have to add atmospheric pressure to this. So therefore, P total is equal to P gauge plus the atmospheric pressure. So that's equal to 39,200 newtons per meter squared plus the 101,300 newtons per meter squared. And you have to take this with a little grain of salt because atmospheric pressure isn't constant all the time. It varies with the weather. Of course, this is kind of an average value, but that's what we do for physics here, take the average value. But when we add those two together, we get 140,500 newtons per square meter. And that would be the total pressure at the bottom of the pool. So why would it be important to find the gauge pressure? Well, for two reasons. If we're standing by the side of the pool, we don't really experience the air pressure. We live in a sea of air, and so our bodies are accustomed to the air pressure, and we don't feel the pressure of the air pushing down our bodies. But once we dive in the pool to the bottom, we do feel the pressure of the water, so it's what we experience. We tend to experience the gauge pressure and not the total pressure because we're accustomed to the air pressure. And for another reason is, let's say we want to take the pressure of the air inside the tire. So we put a gauge on the valve, and of course, that means that the air inside the tire will rush up to the valve, push that little tube out the valve, that then will measure the pressure. And then again, what are we measuring here? And the answer is we're measuring the gauge pressure, which means we're measuring the pressure between the total pressure and the air pressure on the outside. In other words, since the air pressure is pushing back on the gauge in all directions, then the pressure that we're measuring here is equal to the total pressure inside the tire minus the atmospheric pressure. So in this case, let's say that the pressure in the tire is equal to 40 pounds per square inch. What that means is that the total pressure is equal to the gauge pressure plus the atmospheric pressure. And so that would be equal to 40 pounds per square inch plus, and gauge and atmospheric pressure is about 14.7 pounds per square inch. So the total pressure in the tire would be 54.7 pounds per square inch. But then the gauge pressure subtracts that because we have air pressure pushing in the other direction, and so therefore you're only measuring the gauge pressure, and that's also why it's called the gauge pressure. All right? And that's how you do a problem like that. So here you can see very clearly what the difference is between gauge pressure, total pressure, and how atmospheric pressure is simply the difference between the two.